Hello, this is Miguel Rios with Screencast video number 4. Let me share my screen. So this video is about the method of undetermined coefficients. And so right here we have a second order linear non-homogeneous differential equation. Then over here we're going to find a homogeneous solution in order, which is, I said, y sub h, or it could be called a complementary solution. So to find that, you just take the left half of the equation and set it equals 0. So I got y double prime plus 4y equals 0. And then to go from this form to here, you have to put y equals e to the rt, and then take the derivative of that, y prime equals re to the rt. Then the second derivative of that of y is re to the rt. Substitute that into this equation here. You get this form here. Then you divide by e to rt. E to rt is not equal to 0, so this works. And then you get, when you do that, you cancel out the e to the rt. You get r squared plus 4 equals 0. And then you can use quadratic formula to find r, but you don't have to, so I just subtracted 4 from both sides. So I got r squared equals -4, divide the square root both sides. So I get r equals plus or minus 2i. And then you put in this form here where you have a plus bi, comma a minus bi. So a is, in this equation here, this is the general solution when you have complex root. A equals 0, and then the b in green equals 2. And so you substitute the a and b values into this equation here. So you get e to 0t times c1 cosine of 2t plus c2 sine of 2t. This cancels out to 1. So that gives you, for the homogeneous or complementary, you get c1 cosine of 2t plus c2 sine of 2t. So now we're going to find the particular solution. And then for the particular solution, you go by, at first you would think you'll use this form over here, but it won't work because this form over here, a sine 2t, b cosine 2t, is linearly dependent on this right-hand side of the equation. Like this over here is a constant multiple of this. So to cancel out the redundancies, you have to multiply the a sine 2t plus b cosine 2t times c, and that's what I did here. And that's what makes it work. So that's how I got the format of the particular solution is a t sine of 2t, b t cosine of 2t. So you take the first derivative, and then the way you do that, you do the product rule, and then I did the chain rule in my head, as you can see. Like for example, d over dt sine of 2t and dt cosine of 2t. I did the chain rule, but I didn't put on paper. I did it in my head. So you can, and then I'll give you the first derivative of yp is 2a t cosine 2t, a sine of 2t minus 2b t sine of 2t plus b cosine 2t. And then now I'm going to find the second derivative. This is what you're going to plug into the equation later on. Is I did the product rule and the chain rule like I did above, and this is all my work showing my calculations. And then now I'll give you the form -4at sine of 2t plus 2a cosine 2t plus 2a cosine 2t minus 4bt cosine 2t minus 4b sine of 2t minus 2b sine 2t minus 2b sine 2t. And then when you do that, you can see that these two forms match, so you can just add them together. And these two forms in the green match, so you add them together too. And then that's how you simplify. You get -4a t sine of 2t plus 4a cosine 2t plus 4bt cosine 2t minus 4b sine of 2t. You substitute that into your equation here, which is just the right-hand side of the original differential equation. And you put, instead of y, you put yp. So you do y double prime p plus 4yp, and then which equals you take this for y double prime of p, you just write this down all down here, and then you do plus 4. So you're going to add 4 times of y p. So to get that is at sine of 2t plus bt cosine of 2t. So you put that into in this spot over here and multiply by 4. Then when you factor and multiply everything out, you see these can cancel, this form can cancel this form also in green. This form here in blue can cancel this form in blue here. And then that will just leave you with 4a cosine 2t minus 4b sine of 2t. So you're going to equate the coefficients with the right hand of the side of the differential equation over here. And you compare them. So you get 4a cosine 2t minus 4b sine of 2t equals cosine 2t plus 11 sine of 2t. And then you see 4a cosine 2t and cosine of 2t. So that means you'll need 4a equals 1. And then you do negative 4b sine of 2t. And you have 11 sine of 2t. That means negative 4b equals 11. Divide by both sides by 4, you get a equals 104. And down here for b, divide by negative 4, you get 11, negative 11 over 4. And then you substitute these values back into the equation over here. And then when you substitute a and b in there, you get this form over here. And then you simplify t is sine 2t over 4 minus 11 t cosine 2t over 4. And for the general solution, you add the homogeneous equation plus the particular equation. You get the homogeneous from above here, this form over here, and then you get the particular solution over here, and you just literally add them together. And then to simplify this form, I factored it out. So I factor out the C1 and the negative 11t over 4, and then you multiply by cosine of 2t, and then I factor out the C2 and the plus t over 4, and then I multiply that by sine of 2t. And that's how I get my simplified general solution to the entire differential equation. Thank you.